In this video, we're going to talk about the difference between prime numbers and composite numbers. So we're going to start with some definitions. The first definition is a prime number. This is a whole number greater than 1 that has exactly two factors, 1 and the number itself. So a prime number only has two numbers that go into it. So 1 is always going to go into every single number, and then the number itself. So for example, here are the first few prime numbers. The number 2. Nothing can divide into 2 except for 1 and 2. Nothing can divide into 3 except for 1 and 3. And then same with 5, same with 7, 11, 13, and they go on forever. But those are the first few. Next, we have composite numbers, which are any numbers that aren't prime, pretty much. So it's a whole number greater than 1 that has more than two factors. So other things go into composite numbers other than 1 in itself. So like, for example, 4, we have 1 and 4 that are factors of 4, but then also 2. So it's more than just 1 and 4. And then 6 has 1 and 6 as factors, but then also 2 and 3. So all of these numbers have factors other than 1 in itself. So more than two factors, more than two numbers that can divide into them. Let's think about this question. Are there any numbers that are neither prime nor composite? So are there any numbers that don't fit either of these definitions? Any whole numbers, I should say. Actually, both of these definitions say the numbers have to be greater than 1. So what about 1? 1 is actually the one number that is neither prime nor composite because its only factor is itself. It only has one factor. Prime numbers have two factors, and composite numbers have more than two factors. 1, the only number that goes into 1 is 1. So that's the one number that's neither prime nor composite. Actually, 0 doesn't fit this definition either. So it's neither prime nor composite because it isn't greater than 1. And in these definitions, the definitions say a whole number greater than 1. So 0 is technically included in the whole numbers, but it's not bigger than 1. And then every number is a factor of 0, since any number multiplied by 0 is 0. So, yeah, actually 0 has infinitely many factors because anything times 0 is 0. 7 times 0 is 0. 8 times 0 is 0. So it doesn't fit either of the definitions. Okay, so how do we test whether a number is prime or composite? That's the next thing we're going to talk about. Zoom on a little bit here. Okay, so here's what we do. We start with the smallest prime number, and then we stop when we reach a prime number whose square is greater than the number we're testing. Okay, so this might seem a little confusing, so let's look at some examples. So it says, state whether the following numbers are prime, composite, or neither. So let's look at 129. We want to look at start with the very smallest prime number, which we made a list up here. 2 is the smallest prime number. It's actually the only even number that's prime. If you want to add that to your notes. 2 is the only even number that is prime. Okay, so I'm looking at 129 here. And I want to see first, is it divisible by 2? No, because in order for a number to be divisible by 2, it's got to be even. 129 is odd. It ends with an odd digit. That means it's odd, and it can't be divisible by 2. So we're going to try the next prime number and see if that goes into 129. And the next prime number is 3. So is this divisible by 3? Let's use our divisibility rules. Add up the digits. So 1 plus 2 is 3, plus 9 is 12. 12 is divisible by 3. So that means, yes, 129 is divisible by 3 as well. So once we find a number other than 1 or 129 that goes into the number, such as 3, we can stop because that means it is composite. It has a factor other than 1 or 129. It has 3. So if you want to add composite. Okay, let's try another practice problem. So let's try 23. We want to figure out if this is prime or composite. So again, we're going to start with the lowest prime number, which is 2, and see if that goes into 23. Is it divisible by 2? No, because it's odd. 23 is odd. That means 2 cannot go into it. What about by 3? So let's do our divisibility test for 3. I add up the digits. So I do 2 plus 3. That gives me 5. Is 5 divisible by 3? No. So that means neither is 23. Okay, so we keep going. Next prime number is 5. So let's try 5. In order for a number to be divisible by 5, it must end in a 5 or a 0, which it does not. So it's not divisible by 5. So the reason we can stop, so it says stop when you reach a prime whose square is greater than the number you're testing. So we tested 5. 5 squared is 25, and that's bigger than the number we're testing, so we can stop. We can stop and say it's prime. We don't need to test any more numbers. We've tested what we need to. You could test more, but it's not going to be worth your while. So that's how you tell the difference between a prime and composite number. Of course, you wouldn't need to go through these formal steps if you knew right off the bat that a number had factors other than 1 in itself. Like, let's say, for instance, 15. If I asked you if that were prime or composite, you might know right away it's composite because 5 times 3 is 15. So it has other factors besides for 1 and 15.